नमामि शारदां देवी वीणा पुस्तकधारिणीं नमस्कारकरस्मि प्रसन्नास्तु सदा. Yesterday we had finished with the two parts of similarity. Now we are going to start with the third part of similarity, and today we are going to do very important theorem, that is basic proportionality theorem. SSC board point of view, this theorem is very important because this theorem is there on our syllabus from last 25 years, and it is asked in board examination more than 15 times. So it's very important theorem, and we'll very simplify it. If you see the textbook, method of textbook and our method, we'll come to know that this theorem, whatever way we are going to do, same we are doing it. The statement for the theorem is a line parallel to one side of triangle if a line parallel to one side of triangle and intersect remaining sides in two distinct points, then that line divide those sides in proportion, means same ratio. See once again, if a line parallel to one side of a triangle and intersect remaining sides in two distinct points, then that line divide those sides in proportion. As we have studied last time, then is the important word. The part which is given before then is a given part, and after that it is the part we have to prove. See once again, what is the statement for it? If a line divides two sides of if a line is parallel to one side of a triangle and intersect remaining sides in two distinct points, then that line is divide those sides in proportion. Now, what is the given part? If a line parallel to one side of a triangle. So first of all, we'll draw a triangle. Say triangle ABC. If a line is parallel to one side, shall I draw the line parallel to side BC?
No,
okay. Why it is not? Because they are given it is intersecting remaining two sides in. So this will not do. Suppose if I draw a line over here,
no,
it is parallel to third side, but it is intersecting two sides in just one point. This also will not do. So what is the perfect thing? I should draw a line over here. Say line L. Now this line L is parallel to side BC and intersecting the side AB and side AC in point P and Q respectively. Now it is intersecting in two distinct points. So what is the given part now? Given part, line L, sorry, you can write in triangle ABC. In triangle ABC, line L is parallel to side BC. Line L is parallel to side BC, and line L intersect side AB and side AC in points P and Q respectively. See once again, line L is parallel to side BC and line L intersect side AB and AC in point P and Q. So, what we are going to prove? So, we are going to prove that is a part given after that. Then that line divide those sides in proportion. Proportion का मतलब है in same ratio. Line L divide side AB and AC. In which point? Suppose line L divide the side AB in 2 points AB and BB, and side AC in point AQ and AC. Their ratio means what is the ratio? AP upon PB is equal to AQ by QC. They are having same ratio. Which ratio? AP upon PB is equal to AQ upon QC. So, for that, again we are going to do construction. What is the construction? Construction. Draw segment PC and segment QB. Now, if I draw segment PC and QB. So, proof. Now we start with the proof. In proof, see, what I am going to prove? I have to prove AP upon PB, AP upon PB. But AP is a part of which triangle? APQ, and PB is a part of BQC. This triangle are like this. We have completed one property, and I told you that if this type of figure is there, A, B, C, and suppose this is there, then these three triangles, ABD, ADC, ABC, all are having one common height, that is A. So same property you have to use, but now figure will be look like this. How it is looking? Same way. A, B, P, and this is what? Q. Now there are three triangles are there, APQ, BPQ and ABQ, all are having what? Common height, that is maybe say QB. Okay, but now I am not going to draw it. I told you that no, don't need to draw it, just you have to consider. So, which triangle you are going to consider now? AP is a part of APQ and PB is a part of BPQ. So, we are going to consider which triangle? In triangle APQ and triangle BPQ. In triangle APQ and BPQ, Q is a common vertex and A, P and B are collinear points. In such case, they have common height. The height is common. So when they have a common height, then area of triangle APQ upon area of triangle BPQ is equal to base 1 upon base 2. So what you are going to write? Reason for it is triangles having common height. Triangles having common height. Therefore, area of triangle APQ upon area of triangle BPQ is equal to AP upon PB, and I will take it as equation 1. See once again, we have to focus on this part, AP upon PB. AP upon PB means AP is a part of triangle APQ and PB is a part of triangle BPQ. In this case, Q is the common vertex. These 3 points are collinear, means these 2 triangles are having common height, and when the common height is there, means area of triangle they proportional to their bases. You got it? Now, AQ upon QC. AQ upon QC. Same thing is there. We can take triangle APQ and CPQ. So we have to write what? In triangle APQ and triangle CPQ. In this case, P is the common vertex. And A, Q, and C are the collinear points. So I can say that they have common height. If the height is common, then I can say area of triangle APQ upon area of triangle CPQ is equal to base 1 upon base 2. The reason we are going to write triangles having common height. Therefore, area of triangle APQ upon area of triangle CPQ is equal to AQ upon QC will be equation 2 that we are going to do the box. Have you understood this here? When we consider APQ and CPQ, Q is a common vertex and these 3 points are golden. Means these 2 triangles APQ and CPQ have what? Common height. So area of triangle APQ upon area of triangle CPQ will become base 1 upon base 2, that is AQ upon QC. See, what we have to prove for this theorem, AP upon PB is equal to AQ upon QC. Now you got that AP upon PB and AQ upon QC. Means from these 2 equations, we have to prove that their right hand sides are equal. So for that, we'll see the left hand side APQ upon BPQ and APQ upon CPQ. Their right hand, left hand side should be same. So if you see the left hand side, just see APQ, BPQ and CPQ. That 2 triangles are different. So we think for those 2 triangles. Which triangle? Triangle BPQ and CPQ. Now see, these 2 triangles are present between 2 parallel lines. तो हमारे लिए तो अच्छा हो गया. That will mention line L is parallel to side BC. Line L is parallel to side BC means triangle BPQ and triangle CPQ are present between 2 parallel lines. Therefore, they have equal heights. Now, heights are equal, no doubt about this. तो अच्छी बात होगी दोनों का height same है. But BPQ का बेस लेंगे हम लोग. PQ और CPQ का भी क्या है? PQ is the base. So ultimately, they have equal heights as well as have common base. That is PQ. अभी हाइट्स भी इक्वल है और बेस भी कॉमन है, तो अल्टीमेटली एरिया ऑफ ट्राइंगल APQ upon, area of triangle BPQ upon area of triangle CPQ will become 1 upon 1. The reason is triangles having equal heights and common base. Equal heights as well as common base. So ultimately, area of triangle BPQ will be equal to area of triangle CPQ. This is your equation number 3. Have you understood this? Got it? Okay. Now, see. So can I write over here directly? So from equation 1, 2 and 3 will come to know that. Just see. अभी क्या था APQ सेम है. अभी ये भी प्रूव हो गया ना BPQ और CPQ. So मैं बोल सकता हूँ कि from equation 1 and 2 area of triangle APQ upon area of triangle BPQ will become area of triangle APQ upon area of triangle CPQ. अब ये दोनों सेम है. If it is equation number 4, so from equation, or you can write, don't give like this. From equation 1 and 2, what I can write? AP upon PB is equal to AQ upon QC. That's what we have to prove. We can write hence proved. See once again, it's a very important theorem, and that I have given in the form of PDF. I am going to send it, so that from there also you are going to see. Once again, what is the statement for the basic proportionality theorem? If a line is parallel to one side of a triangle intersecting remaining two sides in two distinct points, then that line divides those sides in proportion. So, in this case, line L is parallel to side BC that intersect the side AB and AQ in point P and Q respectively. What we have to prove is AP upon PB is equal to AQ upon QC. What we did the construction is, we draw segment PC and segment BQ in triangle. Now, while doing the proof, we have to concentrate over here. AP upon PB is equal to AQ upon QC. But AP upon PB के लिए हमने दो triangle consider किए, APQ and BPQ, in which Q is the common point. These 3 points are collinear, so they have a common height. APQ upon BPQ is equal to B1 upon BQ because triangles having common heights. So area of triangle APQ upon area of triangle BPQ is equal to AP upon PB, equation 1. And then we are consider APQ and CPQ. P is the common vertex. These 3 points are collinear. They have a common height. So area of triangle APQ upon area of triangle CPQ is P1 upon P2. Triangles having common heights. Area of triangle APQ upon area of triangle CPQ is AQ upon QC. So what we did, we compare equation 1 and 2, APQ, but these two triangles are different. But when we consider triangle BPQ and CPQ, these two triangles are present with two parallel lines, so they are having equal heights as well as PQ is the common base. That's why their area is equal. So if area of triangle BPQ is equal to area of triangle CPQ, so if you compare equation 1, 2 and 3, APQ is the same triangle था, अभी BPQ और CPQ भी same है, मतलब उनका ratio equal है. So from equation 1 and 2, AP upon PB is equal to AQ upon QC. This is the basic proportionality theorem. Possibility of the question which should be asked on what? Basic proportionality theorem. Then if you give the question like this, suppose they are giving the triangle PQR and they are giving ST, say 4, 8, and if they are giving 5, and they ask what? ST. Sorry, they will ask the value of PT or TR. So in such cases, we don't know the value. Suppose they are asked you TR, or they ask the value of X. So in such cases, then what I am going to write in triangle PQR, segment ST is parallel to side QR. Segment ST is parallel to side QR. Therefore, PS upon SQ is equal to PT upon PR. That we are going to write by basic proportionality theorem. What is the we are going to do? Basic proportionality theorem. So substitute the value of it. PS is what? 4. QR is 8. PT is 5 and value of is X. So 4 into X is equal to 5 into 8. X will become 5 into 8 upon 4. 4 ones are 4 twos are. X is equal to 10 unit. A simple way. Whether you got ST is parallel to QR means you are going to apply basic proportionality theorem. What is basic proportionality theorem? PS upon SQ is equal to PT upon PR. So by that way you are going to find out. Suppose they have the value of PT. So what are you going to write? 5 plus X, that is 5 plus 10. The value will become, PR will become 10. That we need and solve it. We are completed with the basic proportionality theorem. Now going to start with the converse of basic proportionality. Converse means what? Opposite of that basic proportionality theorem. Uska ulta karna hai hame. But luckily this theorem is not given as a proof in a textbook. So just we have to see how we have to apply the theorem. But before that we have to study what is meaning of converse of basic proportionality theorem. What they have given to you? If a line divide any two sides of a triangle in same ratio or in same proportion, then the line is parallel to third side. So in such case, I give the example and we have to consider. Suppose I am going to consider triangle ABC and DE is there. They give the value of all the segments. Say they are given 4, 6, 8 and 12. So in such cases, they have given all the values of all the segments. So what you are going to write now? In triangle ABC, AD upon DB is equal to 4 upon 6. So what will be AD upon DB? This become 2 upon 3. Suppose that the equation is 1. Same way you are going to write AE upon EC is equal to 8 upon 12. That is again AE upon EC is equal to 4 2s are 8 and 4 3s are 12. Equation 2. So from equation 1 and 2, what I am going to write? AD upon DB is equal to AE upon EC. So after that we are going to write, therefore segment DE is parallel to side BC by converse of basic proportionality. Alright, we are having only statement of this and we are going to apply. So how to apply it? First we see that what is the statement of it? If a line divides the any two sides of triangle in same ratio, then that line is parallel to third side. So they give the values of all the values of segments, like in triangle ABC, AD ka value diya hai 4, DB ka diya hai 6, A is 8 and EC is 12. Suppose we are giving, the value will be different, but they will do like this. So what you are going to write? AD upon DB. AD ka value is 4 upon 6. What you got? 2 upon 3. Here 8 upon 12. Again 2 upon 3. So ratio is same. So from equation 1 and 2, what you got? AD upon DB is equal to A upon. Once you got the ratio is same, then I can say that line is parallel to remain inside that line. DE is parallel to side BC. And what we are going to write? By converse of basic proportionality theorem. No need to prove it, just see how to apply the converse of basic proportionality theorem. The application of basic proportionality theorem, which we are going to study two more theorems like, but they are the application of basic proportionality theorem. In that, actually, first application is, it is actually theorem of angle bisector of a triangle. Means, like how we are giving the reason by basic proportionality theorem, same way we are going to give the reason as what? Theorem of angle bisector of a triangle. Theorem of angle bisector of a triangle. So, in that case, the statement for the angle bisector theorem of a triangle is, the statement for the angle bisector theorem of a triangle is, the bisector of an angle of a triangle divide the side opposite to the angle in the same ratio of remaining sides. Once again, the bisector of an angle of a triangle divide the side opposite to the angle in the same ratio of remaining sides. You know that, what do you mean of angle bisector then? Angle bisector is the ray which divides the angle into two parts. Suppose, if I am taking a triangle PQR and PT is a bisector, then what, according to this theorem, this QT upon TR. See, kaisa hai? QT upon TR, which is the opposite side, we divide into two parts, QT upon TR, unka ratio is equal to the ratio of remaining side, that is PQ upon TR. ये हमें प्रूव करना है. What have to prove? The angle bisector of an angle, that is angle P, divide the opposite side, that is side QR, in two parts. The ratio of that parts is equal to the ratio of remaining side. Which are the remaining side? PQ upon QR. In students, you have to take care that when you are going to take PT upon TR, that time you have to take PQ upon PR only. So I cannot take like PT upon TR is equal to PR upon PQ. नहीं चलेगा. PT के साथ adjacent side कौन सी है? PR. और TR के opposite side कौन सी है? PR. That's why QT upon TR is equal to PQ upon PR. Suppose they are giving the figure like this. ABC. Suppose BD is the angle bisector. So how you are going to apply it? How you are going to apply it? Just tell me. A. So see that now this triangle, which is the bisector? BD is the bisector. So how you apply it? AD upon DC is equal to AD upon DC is equal to what?
AB
upon
BC.
Right, fantastic. Have you understood this? This way you have to prove. This way you have to apply the theorem of angle bisector of a triangle. But proof of this theorem is given in a textbook, so we are going to do that in detail. Okay? See the students. Now, the way we have given the figure, please take care that you are going to draw the way I have drawn on the board. Say triangle ABC. Okay, see what I did. ये साइड मैंने बड़ा बना है, ये साइड छोटा बनाया है, and this is there. Because by my experience, the students are making mistake to draw this figure. You are going to draw in this way only. Okay. Now, in textbook, they have taken as what? ABC. This they have taken as B and they have taken as what? C. So we are going to do it the same way. Now, CE is a bisector. of angle ACB. Okay, have you understood this? So, students, just tell me what is given. Once again, we just see the set. The bisector of an angle. Which is the bisector of angle? C is the bisector of angle of a triangle. Divide the opposite side. Which is the opposite side now? AB. In the same ratio of remaining sides. Means what they have given to you in triangle ABC, ray CE is bisector of angle ACB. Angle ACB. Okay, and one more point you have to clear that AEB are collinear points, or you have to mention it that ray intersect the AB at point E. Yeah, you are going to write like this. And what you are going to prove? We are going to prove. What are you going to prove? AE upon EB is equal to AC upon
AB.
BC. AC upon BC. AC upon BC. Have you understood?
Start.
Again, we are going to write construction. Construction for this construction, we are going to draw a line parallel to ray CE passing through point B. Means we are going to draw a line which is parallel to CE and which will pass through our BC. These two lines will be parallel, which intersect extended part of side AC in point D. In point D. So we are going to extend this and it is intersecting at point D. So draw a line which is parallel to CE, but these two lines are parallel. And when we extend this side AC, it is intersecting at point D. Okay, have you understood the figure? Have you understood this? Once again, in this triangle ABC, C is a bisector and that intersect the side AB in point E, or you are going to write what AEB are collinear points. Now we are to prove that AE upon BE or EB is equal to AC upon BC. So what construction we did? We have drawn a line which is parallel to CE. These two lines are parallel. And which line intersect this extended part at point D. Now we are going to take care that proof में अभी क्या होगा? Proof. See, these two lines are parallel. First of all, ray CE is bisector of angle ACB. This part is given. So ultimately, when there is a bisector, we know that angle ACE is equal to angle ECB. Yeah, angle is congruent to this is the equation 1. These two angles will be equal. Now we know that line ray CE is parallel to ray BD It is due to construction. Now, if AD is transversal, see, these two lines are parallel. Forget about this side now. These two lines are parallel. This is a transversal. So what I can write is angle ACE is congruent to angle CDB. This is by corresponding angle theorem. Last day we have studied. When the two lines are parallel, then these two angles will be called as what? Corresponding angle, and corresponding angles are congruent. This angle and this angle is congruent because they are corresponding angles of parallel lines. So we got as what? This angle is congruent to this angle. I will draw it once again. See, once again I can write what? Ray CE is parallel to ray BD. Yeah, line BD we can write it. And again, now we can consider BC is a transversal. With a transversal, BC is a transversal. अब देखो कि these two lines are parallel and these two angles, Z forming angle हो गया ना? And we know that these angles are called as what? Alternate angles. And alternate angles of parallel lines are congruent. So, angle ECB is congruent to angle CBD. And reason is I am going to give you equation number 3 by alternate angle theorem of by alternate angle theorem. Now see, this is congruent to this, but this is congruent to angle D and angle ECB is congruent to this. अगर ये दो angle congruent, ये दो angle congruent हुए ना, see that angle equation. One is AC is congruent to angle ECB, but ACB किस साथ है? CDB का, और ECB किस साथ है? So from equation 1, 2 and 3, I can write as angle CDB is congruent to angle CBD. This is again very important. Thus I can take it as equation 4. Therefore, so now we know that these two angles are congruent, means triangle CBD is an now in triangle CBD, angle CBD CDB is congruent to angle CBD from 4. Therefore, triangles, what I can write is triangle CBD is an isosceles triangle. If it is an isosceles triangle, I can write as what? CD is equal to CB. CD is equal to CB, or we can write what? BC. This is equation number 5 by converse of isosceles triangle theorem. See, again, this becomes important. Have you understood this? Now, we are going to take the final triangle, bigger triangle, in triangle ADB. Which is triangle ADB? ये पूरा ले रहे हैं हम लोग अभी. In that, we know that ray CE is parallel to side BD. This is due to construction. अब ये कंस्ट्रक्शन का पार्ट आ गया, so I can apply basic proportionality theorem, and by basic proportionality theorem it will be AE upon EB is equal to AC upon CD. We are going to write by basic proportionality theorem. But instead of this CD, what I can write? BC. So AE upon EB is equal to AC upon BC from 5, and this is your final proof of this theorem. Okay, have you done this? Finished. The second application of basic proportionality is the property of three parallel lines and their transversal. So we are going to give the reason as what? Property of three parallel lines and their transversal. So in that case, the statement for this theorem or this property, the ratio of intercept made on the ratio of intercept made on a transversal by three parallel lines is equal to the ratio of intercepts made on any other transversal by same parallel lines. Once again, the ratio of intercept made on a transversal by three parallel lines is equal to ratio of intercept made on any other transversal by three parallel lines. अब पहली बात यह आता है कि ये इंटरसेप्ट है क्या? हमने तो इंटरसेप्ट पढ़ा था. इंटरसेप्ट क्या है? So you should know what is the meaning of intercept. See, these two lines are intersecting at point A. This is called as a point of intersection. But when a line is there and it is like this, so A, B, C, this A, B, B, C, they are the segments, and these segments are called as intercepts. So there is no spelling mistake. This is the right thing. What is that? Intercept. What is intercept? Segments. They are having some lengths, so ratio of that intercepts. So the question will be asked like this. See, what is meaning of this theorem? The ratio of intercept made by three parallel lines. See, once again, ratio of intercept made on a transversal by three parallel lines. So we can take it as three parallel lines.
Start.
A transversal. Suppose I am going to take this transversal. And intercept made on a transversal by three parallel lines. A transversal is going to T line L, line M, and line N are three parallel lines. Suppose AB and A, B, C are the point of intersections. So AB and BC become intercepts. Suppose the value of it is 4 and 6. So I know that the ratio is what? 2 upon 3. Means AB upon BC is equal to what? 2 upon 3 हो गया. Suppose the value changes, it become like this. Okay, and the value of a मैंने लेंथ यूज किया तो मुझे 2 बन गया, but definitely ये 3 होगा. Again ratio will become what? 2/3. I understood what I'm telling you. या फिर if it is say 3, then this will become 4.5. The value will become what? 2/3. Suppose ये कोई डायग्राम ऐसा एकदम टेढ़ा बन गया और ये अगर 8 हुआ तो ये बन जाएगा 12 और रेशियो will become what? 2/3 only. So that is the thing. What is that? Ratio of intercept made on a transfer. ये transfer करेंगे intercept कौन सा है? This upon this is equal to this upon this. This product. This is the meaning of this. Means suppose the question will be asked like this in your text, in your examination. They may ask the question like ये है ऐसा है question. तो समझ जाना कि these three lines are parallel. Means suppose P Q R S T U है. So we are going to write what? PQ is parallel to PU is parallel to RS. So PT upon PR is equal to QU upon US. This is the property of three parallel lines and their transfers. That's what we are going to do. The ratio of intercept made on a transverse by three parallel lines. So first of all, I will draw three parallel lines. Line L, line M, and line N. These are the three parallel lines. The ratio of intersect made by three parallel lines. And we will draw one transversal. Say transversal. I'll put as what? T1. And it is intersecting these three parallel lines in point A, B, and C. So what is the intercepts? A, B, and BC. So what is the ratio? AB upon AC. Okay? And there is one more transversal is there. Say we'll take transversal T2. And it is intersecting these three parallel lines in point P, Q, and R. So, what is the statement or the property of three parallel lines and their transversal? The ratio of intersect made by a transverse made on a transversal by three parallel lines. What is the ratio? AB upon PQ is equal to the ratio of intercept made on any other transversal by three parallel lines is PQ upon QR. We have to do that. Okay? So, what is given to you? In this case, I can say that line L is parallel to line M is parallel to line N. Okay? And T1 and T2 are transversals. T1 and T2 are transversals. And they intersect parallel lines in points A, B, C and P, Q, R respectively. See once again, line L is parallel to line M is parallel to line N. Okay, and these three lines T1 and T2 are transversal and they are intersecting three parallel lines in point A, B, C and P, Q, R respectively. So, what we are going to prove? We are going to prove that AB upon BC is equal to what? AB upon BC is equal to what?
PQ.
PQ upon QR. That we have to prove. So, Now this is actually very simple theorem. Nothing is there. इतना कुछ headache मारने का जरूरत नहीं है. So we are going to do construction. Construction. Draw segment PC. Suppose I draw this, and segment PC intersect BQ at point D. We are going to take point D. This is your construction. Okay. Now we'll continue with the proof. First of all, I'll consider this triangle CAP. Which triangle are going to prove? That in triangle CAP, line M is parallel to line L. ये तो given है ना? Therefore, segment BD is parallel to side AP. Therefore, by basic proportionality theorem, I can say that BC upon AB is equal to DC upon AD. And for that, we are going to take equation. This is there. By invertendo, we can write AB upon BC is equal to PD upon DC, and I'll take the equation 1. Similarly, in triangle PCR, line M is parallel to line N. This is given. You got it? So, segment DQ is parallel to side CR. So, by basic proportionality theorem, we can write PD upon DC is equal to PQ upon QR. Is equation 2. And now just see, AB upon DC तो PD upon DC हो गया, और PD upon DC तो TQ upon QR हो गया. So from 1 and 2, I can directly write as what? AB upon BC is equal to PQ upon QR. And select